This is Ms. Placino, and you're watching lesson 1.5 on subatomic particles. In today's lesson, we're going to talk about which subatomic particles make up the atom. So we've got a handful of goals for today's lesson. First, you should be able to provide the charge, the mass, and the location of all three of the subatomic particles. You should be able to use the periodic table to find atomic mass, atomic number, and the type of element. And finally, determine the number of protons, neutrons, and electrons in an atom or ion. That last one is the big one for today. We're going to spend some time doing practice problems related to that. All right, let's get into the lesson. We'll start with talking a little bit more about the subatomic particles. You're probably familiar with protons, neutrons, and electrons, but maybe you're a little bit rusty on charge, mass, and location. A proton has a charge of +1. Its mass is roughly 1 U, and if you're not familiar, don't worry. U is a unified atomic mass unit. You might have seen the unit AMU instead, one and the same. I don't really care which one you use. Unified atomic mass units, or atomic mass units, are extremely small units of mass. That makes sense. We use it to measure the mass of subatomic particles in individual atoms or molecules. To give you an idea of the scale, one unified atomic mass unit is equal to 1.6605 times 10 to the -27th kilograms. It is an extremely small, almost impossible to really conceptualize mass. Don't worry, I'm not going to ask you to regurgitate these numbers at any point in time. If you know proton is 1 U, we're in good shape. Finally, protons are found in the nucleus. Neutrons. They're our neutral subatomic particle. They have no charge. They also have a mass of approximately 1 U. For our purposes, we'll treat them as exactly the same mass, and we find those in the nucleus. And our electron, the negatively charged subatomic particle, equal but opposite charge of the proton. Electrons, for our purposes, are massless. In reality, they have a very, very small mass. You'd need 1,840 of them to have the same mass as one proton. So for all practical intents and purposes, we'll consider them to be massless. And finally, we find our electrons in orbitals outside of the nucleus. So a little bit more on the structure of the atom. When we talk about the nucleus, that's where we're going to find our protons and neutrons. It's a small, dense mass at the center of the atom. These rings that we have around the atom, those are called orbitals, and those are the paths that the electrons are going to orbit the nucleus in. The electrons will not go into the nucleus. It just does not work that way. All right. When you think about chemistry, a lot of students immediately just think of the periodic table. That's kind of our unofficial mascot of chemistry. And later this semester, we're going to really be delving into the periodic table, but I want to kind of just get you started with some information now. There is so much packed into each little square of the periodic table, at least the one on your reference table. So if you don't have it out already, dig out your reference table. Each element is going to be found in, I call it an element box. So I happen to have element number 6, C. You might recognize that as carbon. Which of those numbers in that box is the atomic mass? Yeah, it's the 12.001. It's the mass of the atom, and that's found simply by adding up the number of protons and the number of neutrons. That number up there. You might be wondering, well, wait a second, how is it 0.011 at the end? You said that protons and neutrons each have a mass of 1 U. How do I have like a fraction of a proton or a fraction of a neutron? You're getting ahead of me. Don't worry, I promise we will talk about it, just not right now. Which of those remaining numbers is the atomic number? For carbon, it's 6. The atomic number is going to tell us how many protons are in the nucleus, and the number of protons in the nucleus really determines what the identity of that element will be. If it's got 6 protons in its nucleus, it must be a carbon atom. If it's got 17 protons in its nucleus, it has to be chlorine. If it's got 92 protons in its nucleus, it has to be uranium. So that's what we mean when we say that atomic number identifies the element. You're going to see a couple different notations really throughout the school year to represent the elements. Here are some examples for carbon. What do you think the 12 means here? Oh yeah, it's the atomic mass. Well, what about over here? What's this 12? It's the same thing. It's the atomic mass. And the 6? Oh, atomic number. There we go. So just be familiar with those notations. We'll see them again in the practice problems, and we'll just reinforce those concepts. Okay, now when it comes to the periodic table as a whole, the layout is not accidental. Again, we'll be delving into this in much more detail later this term. But for now, I just kind of want to break up the table into 3 sections: our metals, our nonmetals, and our metalloids or our semi-metals. They're 2 different ways of expressing the same elements. If you've got some colored pencils or crayons, you might want to go ahead and start to fill in your periodic table. I'm going to start with the nonmetals. Nonmetals are found to the right of the staircase. And this is the staircase here, the zigzaggy thing. And it's really a great point of reference on the periodic table. If it's to the right, good chance we're looking at a nonmetal. Wow. So I've got those colored in red. Everything to the right. And hydrogen. Hydrogen is just kind of in like a bad spot of the periodic table. There's no good place to put it for a variety of reasons. We'll talk more when we get there. But those are our nonmetals. Everything to the right of the staircase and hydrogen. Our metalloids, or our semi-metals, are the things that are in contact on 2 sides of the staircase. So carbon is just touching on a corner, that doesn't count. However, B and Si, for example, boron and silicon, they have 2 sides of the box touching the staircase. They will get classified as metalloids. There is one exception to that. Let's go ahead and put those colors up. Aluminum. Aluminum, based on its location, looks like it would be a metalloid as it has those 2 sides of its box in contact with the staircase. But aluminum is classified as a metal, as are all the other remaining elements on the periodic table. You might end up with a little bit of disagreement on which of these exactly are metalloids, especially with like polonium and astatine. Those are pretty rare elements, and they don't come up a lot at this level of chemistry. But the remaining 6 are always classified as our metalloids. So just to recap, our metals, everything to the left of the staircase. Our nonmetals, everything to the right of the staircase, and hydrogen. And our metalloids, or our semi-metals, are going to be along the staircase, having 2 sides of their element box touching the staircase, aluminum being the exception. Right. Let's talk a little bit about ions. So we've got this great cartoon. I'm hit, I've lost an electron, says the red atom. Are you sure? Asks the blue one. I'm positive. Chemistry humor. When we talk about ions, we're talking about an atom or potentially a group of atoms that is charged. So an atom or a group of atoms can have a positive or negative charge because it has either lost or gained electrons. That is the only way to change the charge of an atom. We never, ever see atoms gaining or losing protons. Everything that's in the nucleus is kind of just held captive there. It's not going anywhere. The electrons, on the other hand, are free to move around. So whether it is a positively charged or a negatively charged ion, this happened because electrons were lost and gained. Let's be a little bit more specific with the ions. We'll give you some more terms to keep track of. We'll start with cations. Cations are ions with a positive charge. And the way I remember this is the word cation has a letter T in it, and a T is kind of like a little plus sign. So that's how I remember cations have a positive charge. I've also heard kind of more adorably, like a cation, a cat has paw, a positive charge. Whatever works for you is completely fine with me. Cations form when electrons are lost. We know that electrons have charge of -1, so every time I lose 1 electron, that ion will become +1, lose 2 electrons, +2, lose 3 electrons, +3, so on and so forth. Sometimes it's weird for students to think about something being lost and like the charge ending up as positive. But remember, you're subtracting a negatively charged electron. And finally, metals tend to form cations. All of those elements in the previous slide that were just left white, those are metals, and they are going to form cations. Metals love to lose electrons to form positively charged ions. We'll talk about why that occurs kind of as we get moving in chemistry. It's a little above our pay grade right now. If we take sodium, sodium far left of the periodic table, it tends to lose that electron. The loss of an electron gives it a charge of +1, making it a cation. See if you can predict those, or fill in those blanks for anions. All right, anion. Ion with a negative charge. Negative starts with N. There are 2 N's in anion. That's how we keep that straight. Forms when electrons are gained. So there are elements that will pick up these negatively charged electrons, giving them an overall negative charge. Nonmetals tend to form anions. So those were the elements that were colored red a couple of slides ago. Something like chlorine is a nonmetal. Chlorine will find an electron or steal it from a metal, and since we've added that negatively charged particle, it's going to give the chlorine ion a total charge of -1. Okay, so really what we need to do is figure out how many protons, neutrons, and electrons are present in atoms and ions. So before we do practice problems, let's talk a little bit about how we can find those numbers. Protons. Protons, it's a no-brainer. Use the periodic table. No thinking involved. Find the element on the periodic table. It even tells you, like in the key on the periodic table, which one is the atomic number. It's always a whole number. Neutrons, things are a little bit trickier. Round the atomic mass to the nearest whole number. And we can take atomic mass and subtract atomic number. Hopefully my shorthand notation makes sense. For example, we talked about carbon 12. So if I found carbon on the periodic table, it's element 6, so it has 6 protons in its nucleus. Some pretty high level math here. I can take my atomic mass, which is 12.011, round it down to 12, excuse me. 12 minus 6 would give me 6 neutrons in the nucleus of that carbon atom. Electrons are a little bit trickier. If you have a neutral atom, protons will equal electrons. We know that those charges will cancel one another out. However, with cations and anions, you have a little bit more work to do. We know in the neutral atom, the number of electrons is equal to the number of protons. When a cation forms, we know that we have lost electrons. So to figure out how many electrons are in a proton, we can take the number of protons, and then we can subtract the charge of the ion. We looked at sodium, for example. Sodium has 11 protons in its nucleus. When it becomes a +1 ion, it's lost an electron, so I can take the number of protons, in this case 11, I can subtract the charge of the ion, which was +1, and I end up with the total number of electrons in that cation. Really, kind of the same thing works for anions. Number of protons minus the charge of the ion. We also looked at chlorine, which has 17 protons. And then it forms an ion with a charge of -1. So I can take 17 minus 1, I should say 17 minus a -1 would give me 18 protons, 18 electrons, excuse me, in the chlorine ion. That might sound a little confusing at first, so let's do some practice problems, and I think that'll make it easier. All right, so here we've got a handful of practice problems, and I want to go through the first 3 of them together just to practice. So we'll do 1, 2, and 3. And I'm going to skip over the protons, neutrons, and electrons just for the time being, and I'm going to start with classifying that. So for question number 1, I just have F. There's no charge denoted. So this is just an atom. If you use your periodic table, you can look up the name of the element. So I'm just going to switch over to my periodic table real quick. I'm going to find F on the periodic table, and for a lot of you this will be the hardest part of it, just hunting down the elements. Here it is. And you can see there's no name in the box. But if you flip over to the next page, I can see I'm on element 9. Oh, I didn't rotate this page, but we can figure it out. Element number 9, F, that is fluorine. So let's just go back and fill that out real quick. Whoops. Fluorine. Okay, so let's do protons, neutrons, and electrons. To find the number of protons, you really just need to look at the periodic table. Here we go. That number in bold is the atomic number. Fluorine is atomic number 9. We've got this pulled up. We know to find the number of neutrons, we take the atomic mass and we subtract the atomic number. So for fluorine, we have approximately 19U as the mass. I can subtract 9. It's going to give me 10. So I've got 9 protons. I've got 10 neutrons. Electrons can be the tricky one. Since we're talking about an atom of fluorine, we know that this is neutral and number of protons has to equal number of electrons. So in this case, there are 9 electrons in that atom of fluorine. For question 2, we have an ion of some sort. It's got a charge of 2-. Since it's a negatively charged ion, call it an anion. My guess is that you know what element O is. That is oxygen. And just to make sure we're on the same page, let's look at number 3, and we'll go back and deal with protons, neutrons, and electrons. In this case, I have a charge of +3. That is an ion. More specifically, it is a cation. If you were to use your periodic table to look it up, we'd see that element CO is cobalt. What I'd like you to do is to pause the video, see if you can figure out the number of protons, neutrons, and electrons in the oxygen and cobalt ions. And we'll go over that together in just a moment. Okay, we'll do oxygen first. Number of protons, simply atomic number. Based on the periodic table, we know that oxygen has an atomic number of 8. To find neutrons, we take atomic mass and subtract atomic number. The atomic mass of oxygen is pretty darn close to 16. I feel very comfortable rounding that. 16 minus 8 is 8. That's my number of neutrons. Okay, number of electrons. I can take my number of protons and then subtract the charge. So I have 8 protons in oxygen. 8 minus -2 gives me 10 electrons. How'd you do? Hopefully you got them. Up next, we'll look at cobalt. Periodic table to get the number of protons. In this case, it's 27. Number of neutrons, we can take the atomic mass, which is just about 59U. We can subtract 27 to end up with 32 neutrons and cobalt's nucleus. It's an ion, so to find the number of electrons, we have a very little bit of math to do. I can take my number of protons, 27. I can subtract the charge. 27 minus 3 is 24. So there are 24 electrons in this cobalt ion. You'll notice that charges are always in the upper right-hand corner. If there's a number in the upper left, that is telling you the specific mass of that atom, or in some cases ion, of the element. So in like question number 6, Mn, which is manganese, if you look at the periodic table, its mass would round up to 55U. I've given you a very specific mass, so use that one instead. All right, sorry today's lesson was a little bit on the long side. Thanks for tuning in, and I hope you found it helpful.